Hi everyone, in this video we will take a look at how to do the HART communication connections in the DPI 620G-IS. Due to the limitations on the G-IS, which is an intrinsically safe device, there are some sort of protections and some sort of limitations on the voltage can be ignited from the terminals of the calibrator to give a loop supply. In this case, we have some sort of tricks to do the proper connection without losing the, without having a voltage drop which will go beyond the transmitter's operating voltage. The first connection is, but of course, if you wanted to learn more about how to calibrate and how to do the HART function, how to do the HART communication, and do the settings and the adjustments in the HART itself, there is a separate video which I will keep a link on the description box below. Okay, so the first connection we will have, or before we start with the connections, let me brief you quickly about the terminals I'm having. So these two wires, the blue and the black and the red, are the connections connected to the loop terminal of the transmitter. I'm now using the Yokogawa YTA temperature transmitter. So this is the transmitter I'm now communicating with. These two, the red is the positive, the black is the negative, and I have a couple more of flying leads. It's just like a jumpers or test leads. I have the blue and I have the green, which I might need to utilize that. Okay, coming back to the HART. The first connection is the connection when the device is already connected to an active HART current loop. So my transmitter is already connected on the field, it's powered. The HART resistor is already there in the loop, and the system is connected to the DCS through the HART function. In this case, I need to connect my leads here and here. Of course, my device now will not switch on because I don't have power. It's not connected to the network. Channel 2 need to be set on none, so it should not be on current mode. The HART function should be enabled. The 250 loop resistor should be off, so it's off now. The internal power is off as well. And I will connect. So this is the first connection. In this case, the device will operate either primary master or secondary master, depends on how the HART network is configured. The second connection is when I wanted to connect the HART device, which is already powered from the loop, but it does not have a HART resistor. So in this case, I'll connect it to the same two terminals, here and here, and I have to turn the HART resistor off. So this is my second connection, or the second case, let's say. The third case, if I wanted to give an internal loop supply to the transmitter, which is in this case my transmitter, and measure the current as well. So in this case, I have to connect it here on the milliampere terminals, which is having the 15 volt, which is the loop power. So just to give you a quick summary, this is my channel 2. These two are having the loop power. These two are having the milliampere, the passive milliampere measurement. So in this case, I have to connect the negative here, the positive here, and I have to put channel 2 to measure the current with the loop supply. So as you can see, the transmitter is already powered. It's giving 16 milliampere on channel 2, means that it got powered here. But as the internal loop supply is intrinsically safe here, so it has an internal impedance of 100 ohms. At high currents, more than 16, it will start to have a voltage drop, and the voltage might go beyond the operating voltage for the transmitter. In this case, we need to have a different connection rather than that to avoid having that voltage drop. So when the transmitter is requiring an internal loop power, so now the transmitter is requiring a loop power, but I will connect it on parallel, so I will not have that voltage drop. In this case, my connection will be the positive will be connected here, the negative will be connected here, and I have to set a jumper between the loop power terminals so I can power it without having the voltage drop. So now I'm having a wrong connection because power is already on. So in this case, I need just to disable the milliampere here. Disable the current. So channel 2 is set to none. The HART function is already enabled. The 250 ohm resistor is off. This is assuming that the resistor is from the external, and the internal power should be turned on. So the internal power supply without a current measurement. So there is no emitter in the loop. In this case, as you can see, the transmitter is powered. It is giving overrange because there is no input for the terminals of the transmitter. The fourth type of connection, when I need to measure the loop current with a parallel HART connection. In this case, the negative will be connected here, the positive will be connected here, and I have to make a jumper between the positive of channel 2 with the negative of the milliampere. So the milliampere measurement will occur on channel 1 and the HART will be on channel 2. And I have to close the loop by connecting the HART. By connecting the channel 1 with channel 2, so I will have a common positive. The negative is here. So in this case, I'll measure the current on channel 1. I don't have to use channel 2 because it's a HART function. In this case, I will go to channel 1. I get to measure a current. And the internal loop power which should be turned on from the HART menu, not from channel 2. I'm sorry, the way. So again, the settings are channel 1 current measurement, channel 2 none or off. The HART function is enabled here. The loop power is enabled from the menu of the HART. The HART resistor is off. So this is the connection if I wanted to make the communication with a current measurement. So this is the connection, how to connect to transmitters. Let's do the same, but assuming that we have a positioner. So the positioner has a current input, not current output. Let me just get some more test leads. I don't want to inject current to my transmitter. So in this case, I'll be using also black and red for the input of the positioner, assuming, and the other two are jumpers. Here we go. So let's assume that I have a positioner, and these are the positive and negative for my positioner. I wanted to connect it to give it an internal loop supply with current injection or current source. So I have to connect to channel 2 with power. So these will go to the positioner, these two, and the settings should be no need for channel 1 now. I will disable it. Channel 2 will be set to source current with loop supply, and I should also set the minimum current for the positioner before I do the HART. So if it is 0, then no power will be in the loop. I'll set it to the 4 milliampere. Then I can start my communication, the HART. The last case, when my positioner is already powered and I wanted to source current, so I'll source a passive current here without voltage, and I need to do the HART communication as well. So the positioner is already powered from the network. I'll connect the negative of the positioner here and the negative of the power supply, the network power supply here. Oh, sorry. So it's connected here. This will go to the negative of the power supply, and this will go to the negative of the transmitter. And it will be a series connection because I definitely need the power to do to get the current actually. So the channel two function is current source, as we did, and it will be set to the minimum, which is the 4 milliampere, and the HART resistor should be turned on, and then we can do the connection. I'll put a link to a guide which will show you all of these connections and describe the reason behind that difference, because it will show you how the connection, how the impedance is inside. So thank you so much. If you have any questions, please drop it in the comments, and I'll be sure that I reply that. Thank you.